Hello there. In this video I'm going to take a Quansheng TK-11 and I'm going to replace that pesky 3.5mm HF jack with an SMA one. And yes, I'm aware that Paul, Oscar Mike 0 Echo Tango, did a similar video, but what he did, he replaced the LED with a SMA connector and left the 3.5mm jack. Now I got no intention of using the 3.5mm jack. Now you might be thinking, well, wouldn't it be wise to retain that 3.5mm jack so you can use that supplied external ferrite rod antenna? Well, actually you can't, because when you've got that SMA connector adjacent to the 3.5mm jack, the SMA connector obstructs you from inserting the ferrite rod. So I thought I may as well just replace it. And anyway, I think this is closer to how it would have been done in the factory, which I quite like. Okay, so let's roll our sleeves up and get into it. Now, I'm going to assume that you've already dismantled your TK11 and removed the PCB. And if you haven't, there's instructions on how to do this in my teardown video. If you haven't already watched it, now would be a good time to do so. I'll leave a link in the description. Now, before we blindly replace this 3.5mm jack, we should really understand the circuit around it. So you can see we got 5 connection points. Now these jacks sometimes contain switches. The switches can be monitored by the microcontroller. Now this is important because it might be that the microcontroller wants to know if an external antenna is plugged in or not. If an external antenna is not plugged in, it might want to change the filtering, or it might want to change the RF gain and so on. Now you can see that the TK11 jack does indeed have switches, but we'll see that it doesn't actually have them monitored by the microcontroller. So the dotted line shows the area on the PCB where the jack is. You can see here. And then you can see on the jack schematic, we actually have 2 switches, one connected to pin 1, one connected to pin 3. So pin 1 on the jack is the RF input. And then pin 3 is ground. Now pin 2 is often connected to ground, not always, but usually. So consider it ground. Okay, then if we have a look at the jack, you've got 2 switches. The one on the left, which is connected to pin 1, is normally closed when nothing is connected. And then the one on pin 3 is open when nothing's connected. So you can see through this closed switch, pin 1 connects to another connection which doesn't go anywhere. There's 2 pin 3s. There's 2 pin 3 connections, I should say, with an open switch between them when no jack is plugged in. And then pin 2 is connected via a 0 ohm resistor, effectively a short, to ground. When the jack is inserted, you can see that the switches change state. So the switch on the left connected to pin 1 opens, and then the switch on the right connected to pin 3 closes. So now what I want to do is, when I connect the SMA instead of this jack, I want the connections to be the same as if the jack was inserted. So I'm going to have pins 2 and 3 all connected to ground, connected to the ground of the SMA. And then last but not least, I'll be connecting the signal pin of the SMA to where pin 1 is. Okay, so now we understand the schematic and how these switches work. We're now in a qualified position to make changes to the board. Right, I'm going to desolder the jack using my trusty desoldering tool. You could of course use a desoldering pump and wick if you wanted. Give it a bit of a wiggle. The wiggle helps break soldering bridges. Now I'm going to put in a 3.5mm jack just to help me remove this. And then I like to give each of the pins a bit of a wiggle to break any last remaining solder bridges, to reduce the risk of me breaking tracks when I pull it out. Just a little bit of a wiggle like that. I can see most of the solder's gone. That desoldering tool is really good. I'll leave a link in the description if you want to get one. Actually, I often get emails, people asking me what tools I use. So at the end of the video, I'll show you all the tools that I use. How's that? Okay, just clean it up. Looking good. Lovely clean PCB. Now, on the topic of PCBs, I'd like to thank PCBWay for sponsoring this video. PCBWay offer a one-stop hub from everything from quick turnaround prototyping to fully integrated PCB assembly services. They provide a very easy to use user interface. Simply upload your Gerber files, quantity, basic PCB parameters such as type and color, and then they'll provide you with an instant quote. In addition to PCB prototyping, other service capabilities include FPC flex rigid PCBs, advanced PCBs such as HDI, even CNC machining and 3D printing. But my favorite service is the PCB assembly service. Now, as with these beautiful boards from my banana board project, you can either have PCBWay just produce these beautiful looking PCBs, or you can get them to do the difficult bits for you and solder all the SMD components, leaving you to do the through hole. Or of course you can get them to do everything and solder the through hole components as well. So you have a range of options. You can even just get them to supply the kit of parts if you fancy soldering things yourself. For more information, visit PCBWay.com. I'll leave the link in the description. Okay, now let's have a look at the SMA connector that we're going to use. It's a female connector, as you can see there. It's quite long. We'll measure the length, just 1 minute. So if the threaded section is around 13 millimeters long. Sorry for my American friends, I don't know what that is in inches, but you get the idea. Now, when we position it, we're positioning it so the signal pin in the middle goes above the white solder mask, as you can see there. And it will connect to that pin on the top right. And then the ground pins will connect to the existing ground pin connections on the top and on the bottom. So you can see there the connections for ground on the bottom for the 3.5mm jack that we're going to reuse. Okay, now I want to tell you about a challenge we've got. As it is, there's not room between the end of the PCB and the case to allow the SMA jack to be fitted at the end there. So we're going to have to remove that bit of PCB that sticks out. Now normally on a multi-sided, multi-layer board like this, it's a big no-no because you don't know what tracks are underneath that you might cut through. But this, I can see I've got vias going between the two ground planes and it's on the edge of the PCB. There's no point in tracks to be under there otherwise. So I know in this case it's safe to trim that section of the PCB off. Now, if you don't know what somebody's gone completely bananas cutting through a multi-layer board, you might want to close your eyes. Parasol, please, nurse. Okay, so we just clean it up a bit. And then we're going to file the rough edges. Actually, we're going to file and sand it. Now, when you're doing this, make sure that you file with strokes in the same direction as a PCB. And use a fine file, of course. And then fine sandpaper. The reason is that it minimizes the chance of you bridging layers of this board. Remember, it's a multi-layer board. By dragging the file of sandpaper from top to bottom. Okay, so this is what it should look like, nice and smooth. I can't see any tracks in between there. Okay, so now what we need to do is remove the solder mask to help the SMA connector solder firmly and securely to the board. Now I'm going to do this by hand. You could use a power tool, but I don't recommend it because you'll easily damage the tracks and remove the tracks completely. So I prefer to do this by hand. Now to help me solder the SMA, I'm going to tin these exposed areas. Bit of flux first, rude not to. I'm going to use my Finersi HSO1 USB-C iron, about 280 degrees. If you want one of these, I'll leave a link in the description as usual. And Finersi have kindly given us a discount code. Right. This will help you a lot when you solder the SMA on later. Just clean it up to see what it looks like. It's okay. That will make it a lot easier to solder the SMA. And do the same for the other side. When removing the white solder mask on this side of the board, just be wary of the track, which I've shown here in a dotted black and white line. It doesn't appear to be connected to anything, but just in case, avoid removing the mask from that area. I'm now going to prepare the SMA connector. The first thing I'm going to do is bend up the signal pin in the middle of the SMA connector. And this will help keep it away from the ground plane that it will be next to when we install it onto the PCB. I'm also going to tin the connections on the SMA as well. Anything you can do now to make your life easier when you're soldering to the board is an investment. A tiny bit of solder just to coat the surface. I've also pre-soldered the signal wire like so. Now can you see these bottom pins are bent up a little bit? I've done this so you've got a tight fit on the PCB. Now be really careful when doing this because these pins fatigue very easily and will snap off. They don't stand being bent one way and then back the other. So just bend them forward a little bit, test it with the PCB, and if it's not enough, bend it forward a little bit. You just want kind of a nice snug fit when you push it on. But patience and little by little is the key here. Now what you want to do next is just solder one pin. And what we're going to do, we're going to solder one pin and then we're going to check it straight. And when it looks like it's where we want it to be, everything's lined up, then we will solder the rest. So we'll check the alignment. Of course, if it's not right, you can just heat up that one pin and adjust it until it is correct. Looks okay. Right, now for the rest. Okay, so I've soldered all 4 pins and it's really solid. It feels very secure. A quick clean up before we solder the signal wire. Now I'm just using a bit of wire wrapping wire for this actually. I think it's a 26 AWG solid core. I'll leave a link in the description as usual in case you want to get some of this stuff. It's only a few dollars and it just lasts you a lifetime for this type of work. Alright, that looks okay. And solder on the other side. almost done now. Well, on the electronic side anyway. Snip that loose end off. And a quick clean. And there we are. We now have a HF SMA connector. Now just something I want to point out to you is you'll see a large through-plated hole just below the SMA connector, which you can see just here. Just be careful you don't get any solder on it, at least excess solder, which raises the height of the PCB in that area. This is because this mates with the chassis and it needs to be flush fitting. You see those two locating pins there, they go into the holes in the PCB, and if there's solder on them then they won't flush fit. Now an important point, and a lot of people forget this, make sure that where you've got heatsink compound or thermal paste, whatever you call it, you clean up the old stuff and then reapply some fresh compound. You only need a little bit, just to cover the surface, but if you don't, there's a danger that the RF amplifier will overheat. Don't try using back the old stuff, it's not good practice. So having screwed the PCB back to the chassis, don't forget to solder back the wires for the LED. And so this is what the fully assembled unit should look like after the mod. So you can see there the SMA connector fits nicely in that recess that was originally intended for the 3.5mm jack. And of course you still got the LED in place. Now we need to make some modifications to the case. First of all, pull off the silicon cover that was originally covering the 3.5mm jack. And now we need to expand the hole so the SMA connector can pass through it. Now the dotted line shows you roughly where you have to expand the hole. And you can see that the center of the new hole is not in alignment with the center of the old hole. So you can't use a drill to expand it. You just have to have a file to hand and some patience. Now you want to expand the hole to about 7mm or so. It might take a bit of trial and error, but just make sure it's not too tight so you can get the board in and out freely. You want a bit of slack in there. Okay. Looks okay. I might loosen it a bit more to give a bit more slack around it so it's easy to take the board in and out in the future. Now before reassembling it, remember to clean the glass, make sure that's nice and clean, and solder back the speaker and microphone wires. And now the chassis should just pop in as easy as it did when you had the 3.5mm jack. Make sure you got the plastic cover around the mic and speaker jacks. Yep. Now for the screws. Now, even though the new SMA jack is very secure and stable, I'm going to put in the nut as well, just to make sure it's really strong. Because you might be wanting to attach quite a long HF antenna to this, so you want it to be as secure as possible. But even without this, it's really good. Okay, there you are. Now just remove the plastic film off the LED. There. That's looking good. I'm pleased with that. And I've fitted the knob and the battery, and now for a quick test. Okay, so I've already got it on HF, 7 megahertz, and lower sideband. You can see the LED works. Now I'm going to connect it to my DIY mag loop antenna. Oh, a bit of CW there. It's very sturdy, really sturdy. Oh, sounds good. I'm pleased with that. HF is obviously working. And now my OCD's got the better of me. I've decided also just to print a tiny little cover to go over the SMA nut. I thought I'd just finish things off nicely. Optional, of course. Anyway, if you want one of these, I'll leave the link to my Thingiverse site, where you can print one, download and print one yourself. There. I think that is a job done, if I say so myself. Well, I'm going to wrap this video up now, so thank you very much, as ever, for joining me on this video. And I hope it was interesting or entertaining or useful to you. If so, please do join my other subscribers in subscribing to this channel. I appreciate every single one of your subscriptions, and it really does help me bring more content like this to you. Now, before I go, as promised, I'm just going to share with you the tools that I used for this modification. The soldering iron I used was a Finersi HS01. I have a discount code for this as well. I'll leave that in the description. And the desoldering tool I used was the Pros Kit SS331. Again, check the description for the link. So until next time, take care of yourselves. Don't burn yourselves on those soldering irons, and 73.